We now write a formula for the general nth term of this sequence. We are given the first few terms of this sequence. So first, let's understand this sequence. Looking at the few terms, we have the first term is negative 12 third, the second term is 15 ninths, and third term is negative 18 27. And then the number of the pattern continues. So I'm going to consider this sequence as numerator sequence and the denominator sequence, because if you look at the numerator, the first term in the numerator is 12, and then it is 15, and then 18, and then 21, and then 24. I'm just ignoring the negative as of now. We will understand this negative later on. So we say that the numerator sequence is 12, 15, 18, 21, and 24. So here we say that the first term is 12. So I can put the first term as 12, and then we have to add 3 to the next terms to get the next term. So here we add 3, and then here we add 3, and also we add 3, and it continues like this. Or otherwise, to get this number, we say that we should add 1 multiple of 3 with 12, and to get this number 18 we should add, this is 2 multiples of 3 with the first number 12. And likewise, to get 821, we should add 3 multiples of 9 with the first number 12. So I'm going to consider the first number and then write down this as 3 times of multiples of 3. Since we are going to write down the general nth term as n, I'm going to put this as n minus 1. So this is the uh, kind of partial formula for the numerator sequence. I'm specifically writing this as n minus 1 because if you consider the fifth term, that is the fifth term, we are adding 4 multiples of 3. That is, we are adding 4 multiples of 3, which is for the fifth term, it is 5 minus 1. And similarly, if you look at the fourth term, we are adding 3 multiples of 3. So every time we should add 1 less than the nth term multiple of 3. So that is why I have written this 3 times of n minus 1. So now let's understand the denominator sequence. The denominator sequence, we have 3, 9, 27, 81, and 243. So these are basically the powers of n. This is 3 raised to the power of 1, and 9 is 3 squared. uh, 27 is 3 cube, and 81 is 3 raised to the power of 4, and 243 is 3 raised to the power of 5. So the fifth term, it is 3 raised to the power of 5. The sixth term, which is 81, I'm sorry, this is the fourth term. The fourth term is 3 raised to the power of n. So therefore, we can write down this denominator sequence. When we write for an, we can write down this as an is equals 3 raised to the power of n. So this is the expression for the denominator term. And this means we can combine both the numerator sequence expression or the numerator's formula as well as the denominator formula. So as of now, I'm going to write down an, and this equals the formula for the numerator, which is 12 plus 3 times of n minus 1, and then this has to be divided by 3 raised to the power of n. But observe that if you look at the original sequence, the sign alternates. That is, here the number starts off with a negative, and then it becomes a positive number, and then the third term is negative number, the fourth term is positive number, the fifth term is a negative number. Or otherwise, we can say that all terms are negative. This is the first term, this is the third term, and this is the fifth term. These odd terms are negative. You see that it is negative, negative, negative. However, the even terms, that is, this is the second term, and this is the fourth term. These even terms are positive. So therefore we have to take care of that, and for that we can introduce minus 1 raised to the power of n, because minus 1, if you raise this to the power of n, whenever n is even, this quantity is going to be a positive one or just a positive number. And whenever n is odd, this quantity, that is minus 1 raised to the power of an odd power, is going to be negative 1. You can say that instead of positive number, it is basically 1. So this will take care of the sign which is we have in the sequence number. So therefore, finally, we can write down this nth term of this sequence, and this equals minus 1 raised to the power of n, and this has to be multiplied with the formula, that is 12 plus 3 times of n minus 1, and this is over 3 raised to the power of n. Can just put this little bit closer to this one. So this basically represents the nth term of the general sequence.